Picking this problem up again for testing x equal 3. Let's see if I can go out and still see my function. Oops, wrong way. Yeah, so I still see my function at the top. Now I'm going to test x equals 3, again with the same steps that we did before. 1, is f of 3 defined? Well, go and find it. And so when x is equal to 3, there's my function that I use. 1 over 3 plus 3, 1, 6. So condition 1, that's not how you spell condition. Condition 1 is satisfied. So go on to condition 2. If condition 1 failed, you stop there and you would claim that it was discontinuous. So now going on to condition 2. And again, I'm going to write my function at the top of this page here. F of x equals x minus 3 over x squared minus 9. If x is not equal to plus or minus 3, it's equal to e to the x. If x is equal to negative 3, and it's equal to 1 over x plus 3 if x equals 3. So condition 2 does the limit as x goes to 3 of f of x exist. So try to find the limit. So the limit as x goes to 3 of f of x equals the limit as x goes to 3. Again, remember what this means. Close to, but not equal to 3. Well, not equal to 3, I use x squared minus 9. Substitute. I'm going to get 3 minus 3 over 3 squared minus 9. 0 over 0. 0 over 0, indeterminate, means I just need to do something else. And so I'm going to factor. And so that's the limit as x goes to 3 of x minus 3 over x plus 3, x minus 3. Which gives me the limit as x goes to 3 of 1 over x plus 3. 1 over 3 plus 3, 1 6. So I got a limit. Condition 2, satisfied. So then I go on to condition 3. I'm going to go out just a little bit so I can try to get it all out as far as it's going to go. I'm going to go up a little bit, so I want to try to get everything on one page here. So in condition 3, does the limit as x goes to 3 of f of x equal f of 3? Well, the limit was 1/6. F of 3 at the top here, 1/6. 1/6 equals 1/6. Condition 3 satisfied. And so finally, we get to conclude the answer to this problem. So it's continuous at x equals 3. And so the answer to the problem f of x is continuous everywhere except at x equal negative 3. That the only two problem-sum points were going to be 3 and negative 3. Not because that's true mathematically, just because that's what's going to be true in this class. So in this class, the only two numbers that we had to think about are the numbers in the restrictions. In this case, negative 3 and 3. We then test each one of those numbers with the conditions of conditions of continuity. Negative 3 failed at condition 2. So negative 3 was, the function was not continuous at negative 3, but at 3, all the conditions were true, and so we had continuity at 3. So my final answer was that f was continuous at everywhere except at negative 3, at the one number where it failed, the one restriction that failed to be continuous. Okay, the last thing in this section, and then this section will be done. Recall. Let's go in so we can see that a little bit better. A function is continuous at x equal a if the following conditions are satisfied. So those are the conditions we just reviewed a moment ago. Note, the above three conditions are equivalent to saying a function is continuous at x equal a if the limit as x goes to a equals f of a. This last statement guarantees that a function will be continuous at a number if the limit at that number may be found by substitution. That is not to say that finding a limit by substitution is the only way to have continuity in a number. But what it is saying is if you can just find the limit by direct substitution, you are guaranteed continuity at that number. Yes, there are other ways to have continuity, but one quick way that guarantees continuity is if you can do the limit by substitution. That's not the only way if we find continuity. As we've seen in our problems, there are other ways to do continuity. But for some problems, you can verify continuity by just doing direct substitution at the number in question. So, find the limit. Is the function continuous at the point being approached? So find the limit, we start by substitution. And so that's going to be sine of 4 pi over 3 cosine of tangent of 4 pi over 3 plus pi. And now we just start working this out. And when you have a problem like this on a test, if you just punch this in on the calculator and give me the answer, you will not get any credit at all. You got to show me your work. Always got to show me your work. So I'm going to start there. Sine of 4 pi over 3 plus cosine of tangent. Except I don't know why I plugged in 4 pi over 3. How about we plug in the number we're supposed to, which is 0. It's going to make things a whole lot easier. That's supposed to be a 0. That's a problem with lecturing to an empty classroom. People don't correct me. And so I cannot guarantee on these videos that I haven't made a mistake, because usually I'm lecturing to somewhere between 20 and 30 people, and someone usually catches my mistakes. If you find a mistake while you're watching these videos, please let me know and I'll correct them. And these are the first time I've been making videos, there are going to be mistakes. And I should have said that way, way ago in there, probably the very first video. But we start on the inside there, and we've got tangent of pi. So then you have to find tangent of pi. And remember, tangent, if you don't know your values very well, is sine over cosine. So that becomes sine of pi over cosine of pi. Sine of pi is 0, cosine of pi is -1. 0 divided by -1 is 0. So we get cosine of 0. So we do this next. Now we do this. And we get sine of 4 pi over 3 times 1. Cosine of 0 is 1. Which gives me sine of 4 pi over 3. And then you have to give sine of 4 pi over 3, which is square root of 3 over 2. And again, you need to know those basic trig values. So there's the limit, and it says, is it continuous at the point being approached? And we can say yes. Continuous at x equals 0 because the limit could be done by direct substitution. And that concludes this section. So you should be able to do the homework from this section, which I think is section 2.5. That concludes this video.